Hello, I hope I'm audible. Good. Yeah, I think now I should be audible. Okay, so this week I think it was a bit of heavy syllabus. You would have learned about traffic shaping, traffic policing. So unlike the other weeks, let's just dive directly into um, the questions, and we'll start solving a set of them. And I'll give you similar questions for your homework as well after that, right? Um, so some of the major things that went on this week was basically something called DSCP or DipServe, right? And then traffic shaping or traffic policing and traffic shaping, right? So most of the questions are from this area only. So let's just go to the first one. So which of the following statements is or correct? Right. So this is directly from the videos that were shared by NPTEL this week. If you look at this question, they're basically asking um, what exactly is the objective of differentiated services, right? So, or rather, how it works. So, if you notice in in differentiated services, you have the first few bits, which basically chooses the class, right? So, I mean, I'm assuming you've seen the videos, and that's why I'm just going to breeze through some of these questions, and then we'll do some numerical problems at the end of it. So, differentiated services provides guaranteed quality of service. It's not correct. There is no guaranteed quality of service as it is. And it allocates resources on a per class basis. Yes, it does. So this is true. So it reserves resources on a per flow basis. So what is a flow here? A flow is nothing but a set of packets which have the same 5 tuple. Or 5 tuples are same. So what is a 5 tuple? It is basically the source IP, DIP, destination IP, and then protocol, source port, destination port. So essentially, all of these, if they are same on a particular packet, then it's called a part of a flow, right? So it is also it also does not reserve resources based on a per flow basis, so it's also wrong, and it does not use RSVP, correct? So the answer is B, right? So again, which of the following statements are correct? The token service bucket model is primarily used for traffic regulation and IP-based networks. Yes, this is true, right? Because token service bucket is used in IP-based networks, and it is used for traffic regulation. So traffic regulation is nothing but traffic shaping. This is a part of traffic shaping. And I'm assuming you've gone through all the videos, so it's why I'm just breezing through some of these questions. If you have any questions, you can unmute and you can ask me any questions that you feel like you want to ask, right? Okay. So Again, the leaky bucket model is primarily used for traffic regulation in asynchronous transfer mode networks. It is used in ATM networks. This is directly from the video. This is also true. Traffic shaping regulates the speed of traffic that is leaving an interface. Yes. So traffic shaping is basically like you reduce the amount of traffic that is being put onto a particular link because you want to shape the traffic. You want to modify the characteristics of the traffic. Okay? And then per flow based resource reservation puts pressure on network routers. So this is yes. Per flow based resource reservation in the sense you see these 5 tuples that I explained before. So per flow, if you want to check every packet for its 5 tuples and then make a decision based on it, so it definitely puts pressure on the network routers. Because every packet that comes in has to be checked whether it's a part of a flow that you want to uh, reserve. And this is the first point. And second point, you are basically reserving a whole set of resources for a particular flow, which means if that particular flow is not heavy enough, or it's a very light, it's a mice flow, let's say, then the resource reserved goes to waste. It leads to wastage. Therefore, this is also true. So all A, B, C, and D are true. Right? Now this is a numerical. I'll show you how to solve the 2 common numerical questions from this week's syllabus are going to be token bucket and leaky bucket, right? And Maxman. So let's see how to solve that questions. Yeah. Hi, Pace Institute of Technology and Sciences. You want to say something? I can't hear you though. Hold on. Yeah, just a moment. Yeah, please go ahead. You were talking about which question? It is a primary job. Right. Okay. Fine. All right. But I don't know why I was not able to hear you. Were you trying to speak? I believe you were, right? Interesting why I could not hear you. Probably it's a problem with the mic on your side. Yeah, but just you can feel free to just chat as well. Right. Thanks. Yeah. So the last option, you're saying the answer is the last option, right? You're saying which of the following are correct. So the point is per flow based resource reservation puts pressure on the network routers. I mean, um, this is also true. It does put pressure on the network routers. or at least that's what my understanding is. So you can unmute and speak. I mean, everybody can learn from your opinions as well. So I don't know why I'm not able to hear you speak. Is anybody else able to hear this person speak? Okay, thanks. Why do you feel the last option is not true? I'm just curious. You can discuss. I mean, the more discussive the session is, the better. So I welcome all disputes. If you feel I'm wrong in some question, please let me know so that we can come to the right answer. Right. So I'm happy that you're pointing out mistakes, if there is a mistake, there is. So yeah. So this is under dispute right now. He feels that this is wrong. You can't, or rather, no, this is false. But why? I mean, you can say that it is, see, per flow based resource reservation, right? Think of it like this. You want to reserve. So let's say there are 5 computers here. This is a router. Yeah. These are all connected to this router, let's say. So this router is having this much of bandwidth. So this is C1, C2, C3, C4, C5. So then what you do, you reserve this much for C1, and then this much for C2, this much for C3, this much for C4, let's say. Assume, right? What if C1 is not sending anything? So doesn't this amount of bandwidth that is reserved go waste? So which means if a new computer joins, let's say C5, right? So then you have to allocate among what is left out, basically, because it's already reserved to something that's not sending anything. So in this way, it puts more pressure on the router. At least that's my understanding. So why do you feel D is not correct? I mean, you feel free. You can like type the answer out slowly also. Okay, I'll move on to the next question. If you have a reason for why D is not true, please let me know. I mean, I also learned from that. Okay, thanks. So now we'll be doing 3 numericals today. So the first one is token bucket algorithm, right? To regulate traffic. So if tokens are arriving at a rate of 100, sorry, what? 100 tokens per second. Okay. Just one moment. Yeah, if they're arriving at a rate of 100 tokens per second, right? And each token has a size of 100 bytes. How many packets can be transmitted per second? The packets have a fixed size of 1000 bytes. Okay. Oh, fine. So, what are the data points here? They've given tokens. How many? 100 tokens, right? So, a token is nothing like a ticket. It's like a ticket. And each token has a size of 100 bytes. Size of each of them is 100 bytes, right? So, essentially, it's like this. You have a bucket, right, in which you have some tokens. And you can send only as much of data. So you have this particular router, let's say beneath here. So imagine there are two tokens. Let's say there is one and then two tokens inside. You're getting two packets. So and then you're getting three packets. So for the first packet that comes here, one token gets cancelled, and then this packet is sent out, correct? Second packet that comes here, this token is cancelled and it's sent out. But for the third packet that arrives here, there are no tokens left. So this packet is dropped. So essentially what this means is we are regulating the amount of packets or traffic being sent on the egress port based on the number of tokens that are available, correct? Available tokens determine the traffic sent. Okay, and this is the concept is clearly explained in the video, so I'm not going to repeat the whole concept again. So this is a very common template for such kind of questions. And if anybody has already calculated the answer, you can put it in the chat. So again, let's get back to it. So there are 100 tokens in this bucket. Okay, so there are 100 tokens here like this, okay? like this, 100 tokens. What is the size of each of the token? 100 bytes. Correct. So there are 100 items, 100 tokens, and each token is 100 bytes. So what is the capacity here? So so what is the capacity? Okay, so someone has given the answer as 10. Yes, you're right. Good. But yeah, also if you can if you can tell us why answer D is wrong. I mean, for the previous question, it'll be great. Okay. So the capacity is, so what is the capacity of this particular token bucket? So this is 100 tokens, right, into 100 bytes, which is 3, 4, 5 bytes. Correct. This is the total capacity of it. Okay. But now they're asking how many packets can be transmitted per second if the packets have a fixed size of 1000 bytes. Okay, so what is the size of each packet here? So you saw that packets were coming on this end, right? The size of each packet is how much? It's 1000 bytes. So question one, my first question is to send one packet, to send one packet, how many tokens? Yeah, please go ahead. To send one packet, how many tokens are required?
డాడీ తీసుకొస్తాం మీరు పోతానండి
Anu, mute your mic, I think. Unmuting. Right. So to send one packet, how many tokens are required? So the size of each packet is 1000 bytes. So how many tokens is equal to 1000 bytes? How do you calculate that? You just divide the size of the packet is equal to size of a packet divided by size of a token, which is equal to 1500, which is equal to 10 tokens are required to send one packet. So basically, you need 10 tokens to send one packet. So now, how many tokens are coming in per second? 100 tokens are coming. So how many packets can you send per second? Is equal to the number of tokens arriving per second divided by number of tokens required for one packet, which is equal to 100 by 10, which is 10, right? So the answer is 10 packets can be sent. All right. So I'll give you a minute to see this, and then if you have any questions for this, let me know. It can be as basic as possible. It's completely fine. It's for you to learn, right? Just let me know. All right then. So let's move on to the next question. So this is the leaky bucket algorithm. So consider a network that employs a leaky bucket algorithm. If you want to know the explanation for leaky bucket algorithm, you can go and look at the videos for traffic shaping. The system injects 25 megabytes of data into the network. Okay, so let's start drawing the diagram for this or something like that. So how much input data? Input data is 25 megabytes. Twenty-five mega. It's bytes. So because everything is in bits, megabits here, let's convert this to bits. Okay, so 25. Right? How do you convert it into 8 megabits? So this is 200 megabits. So this is the amount of data that is being put into the network. Okay, so point one. So the data is generated and transferred in bursts of 10 Mbps. So this 25 megabytes is not directly put into it. It's like it comes in bursts. 10 Mbps and then a break, and then 10 Mbps and then a break. Something like something like that. So that is basically called the rate of data generation. Okay. And that is equivalent to 10 Mbps. This is small b, which is megabits per second. Okay. So what is the minimum buffer size required to prevent data loss if the minimum sustainable transmission rate across network routers is 5 Mbps? Okay. So the limit equal to 5 Mbps. So so essentially, this is how you can picturize it. You have input data that is coming in to the network. Okay. And this is how much 200 megabits. And this was from 25 MB. Correct. So this is 200 megabits per second. And this is coming in bursts of 10 Mbps. Correct. But this bucket has to send into the network only at the rate of 5 Mbps. Correct. So this much data is coming. So they're asking, what should be the size of this bucket so that data loss does not happen? Okay. So why will data loss happen here? Because the amount of data you're putting in is more than the amount of data that's going out of a bucket. So eventually this bucket will tend to overflow. Correct. This is logic. So but the data is not coming continuously. It's coming in bursts of 10 Mbps. So with that in mind, if you keep the size of this buffer, this buffer, the buffer is nothing but the leaky bucket. So if you keep the size of this bucket in a particular way, then you won't lose data. So what should be the size of this bucket is what they're asking. Okay. Is the question understandable? I think it should be. Okay. Right. So to solve this, let's take the duration, or rather the burst duration. Okay, they're saying the burst is 10 MB per second. Right. So when you consider 10 MB per second bursts for 200 megabits, right? So the burst duration is equivalent to the data size, which is 200 megabits, okay, by 10 megabits per second. Okay, so this megabits gets cancelled, and the second goes up, and this. So this becomes 20 seconds. Simple. So the burst duration. So basically, the data is going to be sent in durations of 20 seconds. Okay. So far clear? Next question. In 20 seconds, how much data should be transmitted So basically 5 Mbps should be transmitted in 20 seconds. So in the sense, the total, right, the total amount of data that can be transmitted in 20 seconds at the rate of 5. I think that I should have framed it differently. So this 5, where is this 5 coming from? This 5 is coming from here. So in 20 seconds, how much data can go out of the bucket? Okay, how much data can be transmitted? Okay, it can be transmitted. So the rate is 5 Mbps and the time is 20 seconds. So if you multiply both of this, right, this is going to be 20 seconds into 5 megabits per second. Second cancel, so it's going to be 100 megabits. So now we know that the bucket can empty at the rate of 100 megabits every 20 seconds. Okay, right. But what is the input? The input is 200 megabits. So the bucket can empty at 100 megabits every 20 seconds. But how much is coming in? Data coming in every 20 seconds is equivalent to 200 megabits. So essentially, this bucket here needs to hold 100 megabits extra, more. So how does that happen? You subtract this from this. So size is required buffer size. (200 minus 100) is equal to 100 megabits. So the answer is 100. So I mean, I've solved this in a logical way. So I mean, see if you can understand this. If not, then I can explain the whole thing again, or parts of which you could not understand. Okay. So the size of the buffer is going to be 100 megabits. Why? Because as soon as 200 comes in, 100 of it goes out because it leaks at 100 megabits every 20 seconds. So what has to be left out there in the bucket? Another 100 megabits, so that you don't lose any data. Okay, so the next question is about Maxmin hash scheduling algorithm. Right, this is pretty simple. Yeah, so there is a There are 4 users having bandwidth demands of 2, 2.6, 4, and 5, right? So the total bandwidth available is 10 Mbps. How much of bandwidth is allocated to U4, user 4, when the router uses maxmin for scheduling algorithm? So what is maxmin? I'll just write down the 3 major points. Resources are allocated in order of increasing demand. No source gets a resource share larger than its demand. Okay. And finally, sources with unsatisfied demands gets an equal share of the resource. Okay. Okay, so these are the 3 major points. So given this particular capacities, right? So what are the capacities here? Required is 2. So U1, U2, U3, U4. U1 has asked for 2, 2.6, 4, and 5. Correct. All the units are in Mbps, so I'm not writing the units separately. Right. So step 1, what is supposed to do? You need to calculate the capacity. So the amount of available bandwidth as per fair allotment. So by fair allotment, capacity is what? 10 Mbps. Sorry, 10 divided by how many other? 4, which is going to be somewhere around, it's exactly 2.5. So what does it say? We can allocate 2.5 to the user with the least demand. So the user with the least demand is first U1. So U1 has been allocated how much? 2.5 has been, so 2.5 can be allocated, but user 1 only wants 2. So how much you're allocating? You're allocating 2 to user 1. Okay, I'm writing this in bracket, how much you've allocated. So when you allocate 2 to user 1, how much bandwidth is left out? So you have a left out bandwidth of 8. So left out is 8. Why 8? Because you're allocating 2. 10 minus 2 is 8 is left out. Right. Next. Now 8 is left out. How many users are left out now? 3 divided by 3. 8 divided by 3 is how much? 8 divided by 3. 8 divided by 3 is 2.666. Let's make it 7. Okay, 2.667. So 2.667 Mbps can be allocated to each of these. So which is the smallest one among these 3? It's U2. So I'm allocating 2.6 to this. So how much is left out? Left out is, already there was 8. So 8 minus 2.6, which is um, okay. Okay, let's keep this as 2.6666, right? Zero six six. Something is wrong with the numbers. You just give me a moment. Okay. Yeah, so it is 8 minus 2.6, and what does that come to? It comes to 5.4. So 5.4 is left out right now. For how many? For two of these, U3 and U4. So now capacity is 5.4. So 5.4 divided by 2 is how much? It is 1 point, sorry, 2.7. This is 2.7. So you can allocate 2.7 to both of U2, U3, and U4. So out of which you are allocating 2.7, basically. You're allocating 2.7 to this. And whatever is left out, you're also allocating 2.7 to this, because you can't allocate any more than 2.7, right? So the answer is actually 2.7, I think. So the closest answer to this is C. But I'm wondering, yeah. So you won't get questions with the wrong answers. The answer is 2.7. So the closest one here is 2.665. So you can choose that and you can go ahead. Right. Yeah. Just confirm one thing. So as per me, the answer is 2.7. So you can follow what I'm saying here. Yep. The answer is 2.7. Okay. So with this, I think the numerical part comes to an end. I'll just quickly tell you the answers for some of these questions, which you can go and you can try them out by yourself as well. Right. So for this question, which of the following statements is/are correct? Oh, sorry. This is one. Yeah. So the differentiated services field in the IP header occupies 16 bytes, 16 bits. No. Directly from the. So this is directly from your videos. I'm not going to explain much. So 4 bytes are allocated for IP precedence in the IP4 type of service? No. 3, right? So shapers delay some or all of the packets in the traffic stream. This answer is true. This is correct. And differentiated service model is based on using per hop behavior. Yes, this is also true. So answer is C and D. Okay. Seventh question is, what are the first 3 bits in the DS field indicate? The first 3 field is basically the class selector. This is from previous question, right? It's class based reservation. So the answer is B there. And 8. If a customer requires normal reliability, which bit of the type of service field should be set or unset? So this is directly from the theory there. So you have to keep that in mind. So the answer is B. Sorry, it should be right. It should be unset. So which means it is B. Answer is B. Yeah. 9. This is basically looking at the code. So packet P needs to be sent with assured forwarding class 4. So there is a table in the videos. If you look at the table, the answer is directly from there to be set. So what is a binary bit sequence? You have to like make that bit sequence, but this is completely directly from that particular table. So the bit sequence, you can do this by yourself as well. So the bit sequence is A. This is a very direct question, right? So the answer is A. And then finally, question number 10. So the number of bits reserved in the type of service field is how much? Simple. TOS is 2. Oh, is it 3 bits or is it 2 bits? Check. I think it depends on the kind of model that we're talking about, right? So that's another dubious. Oh, it's 2 bits, right? Or is it 3 bits? Let me check. Let me just be sure about it. Oh yeah, it does look like it's 3 bits, but yeah, I think you're right. You guys are right. So again, this is directly from the videos, right? And type of service. Yep, it does. It does look like it's 3 bits, but yeah, I don't know why the official answer here is 2, but okay, I'll confirm with you probably. But for now, I think you're going to like the answer 3 bits. So for these questions, the next set of questions, I'm just going to give you the answer. You can work it out by yourself. I've given you the method also for the previous questions. For this token bucket algorithm, the answer is It's very simple. It's very simple to do this also. So for this particular question, the answer is A. Answer is 5. So this quickly we can do this also. So it's like the tokens are arriving at 200 tokens per second. Each token has 5 this thing. So 200 into 50 is equal to yeah. So this is the total capacity. How many packets can be transmitted if a fixed size of 2000 bytes? So divided by 2000 is um, equal to 5 packets. Right? I'm just doing it directly. Okay. But if you want the actual method, you can follow whatever I told before for the previous question. It's a very similar question to that. So this is assured forwarding, right? This is complete theory. So here, which range of class is known as assured forwarding service levels? So the answer is A, 1 to 4. I'm just giving you the answers. You can verify it also. If something is wrong, you can contact me. Which of the following conditions are valid for max-min fair share algorithm resource allocation? So I think I wrote down 3 points, correct? So which are the 3 points? It's A, C, and B, right? And so this is leaky bucket once again. If you follow the same method that was told to you, you will end up with an answer that is C, 32 megabytes. Yeah, that's the answer. I'm just directly giving you the answers right now. And the differentiated services field of DSCP, what do the first 3 bits and the next 3 bits indicate? This is pretty straightforward. It's a class selector and drop precedence, right? So which of the following per hop behaviors is associated with DSCP value 101110? So this is expedited forwarding. This is directly from the table. You can take a look. So what are the main types of services provided by integrated services? So integrated services is the one that comes before differentiated services, right? So it's actually from the previous lectures videos. But again, the answer here is controlled load service and guaranteed service, because integrated services, it tends to reserve a complete set of resources for a particular set of flows or something like that. It partitions the whole set of resources. So the answer is C for this. What is the correct statement among the following related to integrated services and differentiated services? So integrated services involve prior reservation of resources for the required quality of service, while differentiated services mark the packet with priority and send it to network. This is exactly correct. No, there is no marking here. Integrated services uses a model based on service classes. Nope. This is also not correct, and this is also not correct. This is pretty straightforward. Next question. Here the following statements are is/are incorrect about circuit switched and packet switched networks. Incorrect. So circuit switched networks use a dedicated path for communication, whereas packet switched networks utilize a shared path. So this is true. In circuit switched networks, resources are not reserved. No, it is reserved. So this is false. becomes false in the first sentence itself. Circuit switch networks employ a variable transmission rate for communication, while packet switch maintain no. Circuit switch maintains a constant rate of transmission because it's assured and it's reserved. Circuit switch networks do not need to establish dedicated channels for communication. No, this is also false. These the answers are B, C, and D. I know I'm going fast through all these questions. If you didn't understand any of these, please just you can raise your hand right now as well. Okay. Uh, so consider the 10 users. So this is also similar to that fair share or that maximum question that we solved, and the answer to this question is C5. You can verify. You can do this for yourself. And yeah, let's cut short today's session at this much. We've done almost 20 questions, and if you have any questions, you can ask. I'll be here for another 5 to 10 minutes. Right? Okay. And I'll put up the PDF right after the session. Okay. If you have any questions regarding any of these, you can please contact me at CS21RESCH11009 at iith.ac.in. Okay. I'm sure you wouldn't have any much questions, or even if you have questions, you can find out the answer on the internet. But still, I'm just putting it out there for you folks. Thanks, sure. But again, um, I feel the three different types of numericals that you get, you have these three major types of numericals from this set of questions. So those were the main objectives for me today, to tell you how to solve those three types of questions. And you can practice the other three that I just give you the answers for, and you'll be done probably. So, Okay, guys, thank you. I'll end the session.